Now here we're given sine theta is 12 over 13. And what you're asked to find the two other primary trigonometric ratios of angle theta. So this is a right angle triangle, and for angle theta, we can name the various sides. So if we label this as theta, then the right angle, which is here, the side opposite the right angle is going to be our hypotenuse. And the side opposite angle theta, our opposite side, will be this side here. And we can also identify our adjacent side, which is the side next to angle theta. Now we're told a couple things. First of all, sine theta is 12 over 13. And so remember that sine is opposite over hypotenuse from SOHCAHTOA. So we can now label on here, because sine theta is 12 over 13, our opposite side, it must be 12, and our hypotenuse must be 13. So we can label those on the diagram. So now we know our opposite side and our hypotenuse. We don't know the length of our adjacent side, but we can use Pythagorean theorem to find the length of the adjacent side. So Pythagorean theorem is, remember, c squared equals a squared plus b squared. And c is always the hypotenuse, so we're going to sub in for 13 for the hypotenuse. And we'll let a be our adjacent side and b be the opposite side. So 13 squared is equal to a squared plus 12 squared. So we're just subbing in the values for our opposite side and our hypotenuse into the Pythagorean theorem. And if we square 13 and square 12, this simplifies to be 169 is equal to a squared plus 144. And we now have to solve for a. So the first thing we can do is subtract 144 from both sides. And a squared then is 25. To find the value of a, we have to take the square root of both sides, which it leaves us with a equals 5. So now we know the adjacent side. And so that's 5 centimeters or 5 units. This could be feet, any unit at all. So now what we're going to do is write our tan ratio. And remember from SOHCAHTOA, tan is opposite over adjacent. So tan theta is going to be 12, which is our opposite side from angle theta, over our adjacent side, which is 5. So our opposite is 12, adjacent is 5. So the trig ratio for angle theta is 12 over 5. Cosine is adjacent over hypotenuse, and so for angle theta, the adjacent side is 5, the hypotenuse is 13, so our trig ratio for our cosine ratio for angle theta is 5 over 13.